Joe, can you hear me?
Yes.
Yeah, I'm okay with the address. I just need the bin thing.
The bin things, huh?
Yeah.
Mm, um, then the table.
The table, I'm okay also with how to do the table. I just don't understand how to do the bin, like when to
Put it
actually
and
add
when
it.
to put it. Yeah, let me just explain you that so that I will go back with Moapi to do the table because maybe the problem for him is just a table. Uh,
Okay.
so the concept is such that remember that we have two cylinder, and with the two cylinder, whatever the name they're gonna give it, A, B, or C, and then S. So, for instance, if I take the color blue to determine that when my cylinder A will go on and when my cylinder B will go on. So with design one, you're gonna observe that cylinder A went on first, and then on the second it was cylinder B that went on. And then you have cylinder B went off. Then you have now cylinder A went off. So you can see that you have a link between the two cylinder. I went on, cylinder A was on, then cylinder B went on, cylinder B went off, then cylinder A went off. So you can see that there is a link between the two. They are depending on each other.
Okay.
Automatically we don't need a storage because they're depending on each other. We don't need to put the storage between the two. That's the first reason. Okay. So let's go back on the case where we have to put the storage and see what's happened there. In the case where we have to put storage, we're going to see that A went on and then it went off. Then B went on and then it went off. So you can see that in this second design, you were observing that when one of the cylinder is in operation, the other one is off. This one must go off so that cylinder B will go in operation as well. So they are independent. So in order for us to make a log, we need to put a storage here. And the purpose of this storage is to make sure that if one of the cylinder is in operation, the other one should not be in operation. And then once B start becoming operation, there is no need for A to go in operation. So that's the purpose of that storage. So every time that they give us the design, what else we are going to do is to go in our logic order. Let me take the logic order. For design one, the logic order is this. So I will use the blue, for instance. So I'm gonna see that here, this is design one. So here it went, cylinder A went on here. And then the pink cylinder B, it went on here. And then cylinder B went off. Then cylinder A went off. Can you see that we have a on off. So you don't need to put the storage because the two are depending on each other. When I'm in operation, the other one also is in operation. Then once when one of them went off and then the other one went off. So they are depending on each other. I can be in operation while you are in operation. So there's no need to put the storage. You get a picture?
Yes.
Yeah, so the same is also applicable for when you look at design 2. I think this should be design 2. Yeah, design 2 is here. So on design 2, what we observe is that we have a cylinder A went on here and then it went off there. Cylinder B went on here and then it went off there. So you can see that we have a on off, the two that are not depending on each other. One should be in operation, the other one should be off. And then when this one is in operation, the other one should be off. Automatically, we're gonna come and say we need to put a storage between the two to make sure that when one is on, the other one should be off. This one must go off, then this one will be on.
You can do the whole table.
The whole table for this one.
Yes.
Yeah, but the question now is we need to identify which switch was closed so that we can start the operation for the second cylinder. Can you see that? And then the switch that we always gonna consider is gonna be the last one. No matter which name they're gonna give it, switch 8, switch 10, or whatever. The switch that is going to switch off cylinder A, so that when cylinder A is off, now we can start the operation of B. That should be the switch of the storage, and then in this case it's switch 1. So we're gonna say switch 1 was closed. So you get a picture.
Yes, I understand.
Yeah, so even if it was switch 7 here, we consider switch 7 was closed. Yeah. Moapi, are you there?
Yeah, listen.
But you get the picture of this one as well. It's a revision already that we made on how to identify when to put the storage and when to not put the storage.
Yeah, I can see what's it doing.
Yeah, okay. So let's go back to the table. And then with the address, we know already how to do the address. So we're just going to discuss the table. The drawing. The drawing, is it clear how to do the drawing for this ladder diagram?
Yes.
Yeah, this one is clear. Yeah. And then yeah, let's discuss about it, because I think this one maybe you will need to understand it as well. So as you can see, what is that? Let me take one. Where is it? Okay, yeah. So as you can see, we have two switch, and then sometimes you're just gonna hear that S2 was initially closed, and then you see, did you get that part of when say S2 was initially closed?
Yeah.
Yeah, so it's like we have a weight in the middle here, which is swinging between up and then down. So if this weight is up here, which means switch 2 will be closed. When it's moving away, switch 2 will be open, then switch 1 will be closed. It's always like that. And then initially, we're going to consider this weight to be on top here, so that switch 2 will be initially closed. When it starts moving away, there is no any weight anymore on 2, which means switch 2 will open. And then if switch 2 is open, when the weight reach the maximum depth, switch 1 will come close. So that's how it's playing around. Even from this side also is the same. The weights move from the left to the right, from the right to the left, and then that it. And then now we can do the table. So I'm just gonna give you a tip on how to do this table, because we need two information in order for us to not get it wrong. Let me take that. Okay. Yeah, so the idea when we're playing around with the table is that we're gonna use this diagram here to determine our input. Okay, because we understand the swinging movement, the weight is up or down, and then if it's up, you know what's happening, that the switch that was up was closed. If it's moving away, it's become open. When it reaches maximum depth, it's become closed. So we're gonna use this one in blue here to determine our input. And then automatically, what you are going to observe is that initially, the start bottom it's closed. Switch 1, as you can see, switch 1 is down here. So it's initially open, it's 0. Switch 2 initially closed. Why? Because we consider the weight is always on top there. And then we have a 1. And then you have your switch 3. But sometimes I'm just going to play around with the notation of the switch. He's going to call it switch 10, switch 11, but the concept is still the same. Just identify where you have your switch 10. And then here we have switch 3. Initially will become open. Switch 4, because of the weight, it's going to be always start from the left. It's going to be closed. Okay, that's how we play around. So we're going to use that diagram to determine our input. But when it comes to the output, we're going to use the logic order to determine our output. Because every time there will be a switch that will be closed in the circuit, something must change on the output. If a switch is open, the output will remain the same. Get that what? If a switch closed, something must change on the output, which means if, for instance, switch 3 is closed, must come here in the logic order to check when switch 3 is closed, what's happened. I can see that cylinder B went off. Okay, so that's how we're gonna do. So if a switch open, we don't need to change anything on the output. The output will remain the same. Okay, so on the first step, it says press the start button. What does that mean? If I press, it's gonna be closed. A closed switch, it means you have a 1. And because I have a 1, I must check in the logic order to see what was the change when you press the start button. And then you can see that cylinder A went on. So we come here, we say cylinder A went on, B remained the same, and then in the input, everything will always be the same. It's only one change that will occur. So which means this will remain the same. It's only one change will occur. Happy? You still okay there?
Yeah, I'm still okay.
Yeah. Step 2, release the start button. What does that mean? It means I release there. Now it's open. And I said every time a switch is open, we don't need to change anything. So a switch was open, everything in the circuit will remain the same because the switch was open. Okay. And then on step 3, it says cylinder A start to drill. Okay. So remember you have a weight which was on top there. If it starts to drill, which means the weight will move away from that, and then it can be somewhere in the middle here. So it's still drilling. So the change that will occur is that switch 2, the switch that is up here will open. Can you see? And then if a switch open, automatically we know that nothing will change in our diagram. everything will remain the same because a switch is open. Okay. And then we move on step 4. Step 4, it says complete the first wall. Complete the first wall. What does that mean? This weight which was on top there, start drilling, and then now it's complete, which means down here. So this which is down is going to be closed now. So that will be the change. So switch 1 will be closed. And then we say every time a switch is closed, we go to the logic diagram, and then we identify switch 1 is here. When switch 1 is closed, cylinder A must go on. Then you come here, we say cylinder B went on, and everything remained the same. Can we see that? CP, Moapi, everything, it's clear on step 4?
Yes.
Yeah.
Okay. And then step 5, it states cylinder B starts to drill. So remember, we still have a weight which was on switch 4. Now this weight move away. Let's say it's somewhere in the middle here. So you can see that switch 4 will become open, and therefore the only change will occur is switch 4 will open. And when a switch open, everything in our circuit will remain the same because the switch was open. Okay. And then
Yeah.
6, cylinder B reach the maximum depth. What does that mean? It means this weight was there. Now it's on the maximum. It's somewhere there. So it's gonna close switch 3. So if switch 3 is closed, switch 3 is closed. And every time a switch is closed, we go in our logic diagram, which we see switch 3 is closed. Because switch 3 was closed, cylinder B return, which means it's gonna be off. So you come here, you put a 0 on B, and then everything else will remain the same. Still on the same page, eh?
Yeah.
Yeah.
So once it reaches the maximum depth, that means it's off. Like it's done drilling, right?
Yes. So it's like I was here on top. When I start drilling, remember it's a can be a metal or a wood or what. So it's not gonna go into maximum yet. It's just it needs gonna drill until it reach the maximum depth. So it's just a word reaching the maximum depth, or if you can say it completes the first wall. It's the same meaning.
Okay.
That means it's the switch which is down here must be closed because now it's at maximum. Yeah. And then on step 7 is cylinder B start to return. Cylinder B start to return, which means the weight which was here now is moving away. It's moving away from switch 3, from this switch. So it's gonna be somewhere maybe in the middle. So the only change will occur is that switch 3, this switch here will become open now. Will be open, and every time a switch is open, everything will be the same. Nothing will change. And then on step 8, it states that cylinder B completes the return. Complete the return. It means the weight of that cylinder now will close switch 4 because it's back on initial position. And then when the switch is closed, we must look at our logic diagram and see that switch 4 is here. When it's closed, cylinder A must return, which means it must be off. And then you can see that you have a off there, and everything else remain the same. On step B, in step 9, it says cylinder A start to move back. Cylinder A start to move back. What does that mean? This weight which was down here now is moving away. It's moving away. It's moving away, which means it can be somewhere in the middle. And therefore, the only change will occur is that switch 1 will open. So we go to switch 1. Switch 1 become open. When the switch is open, everything in the circuit will remain the same. Yeah. And then on step 10, it says cylinder A is back. Cylinder A is back. It means this weight, which was maybe in the middle, now it's on top there. So which means switch 2 will become closed. So the only change that would become there is that switch was on top. Whatever name is going to give it will be closed. And then we say every time a closed switch happen, we must check in the logic order. And then when you check in the logic order, there is no any switch 2. So which means nothing will change. And therefore, we have a 0, 0, 0, 1, 0, 0. And then from what is said, 10 and 0 must be the same. So we can see that the two are similar. Can you see how?
Yes.
Yeah, so that's basically how to play around with this cylinder when it comes to design 1. But in the case of the binary input, the storage, there's not much difference. It's basically the same concept. So if you know how to do our leader diagram for the circuit design, we should know also how to identify. I'm sure this one is clear as well. The second design, the address and the drawing. The leader diagram for the second design. When you have a binary, it's always going to be like this, but you just need to identify your switch and everything. So this switch here will be the switch that is going to start to switch on our cylinder A, and in this case it's the start button. So we're just going to take the address for the start button, we put it there. This switch should be the switch that is going to switch off cylinder A, and then in this case we can see that switch 1, and then this switch would be the same as that one, so they're gonna have the same address. Because cylinder A will go off, and then the binary, when switch 1 was closed, is when it must go on. And here, as you know, our output have the same address as that one, and then our binary will already have the same address as that one, and then because of this case, this will have also the same address. And then this switch here is the switch that's gonna switch on cylinder B, and in this case we have a switch 2, And then, as we know very well, our output here will be the same as that address there. And lastly, this is the switch that is going to switch off cylinder B. And then in this case is switch 3. So we're going to take the address of switch 3, and this will be the same as that one. So that's how you put those addresses. I could explain it why, but maybe we don't really have much time to explain it why, but it's always be like this. Okay.
Yeah.
Yeah.
So let's just go into our table. So this is going to be our last thing to do, and then we're going to discuss about the error condition, how to solve them easily, because they're really easy if you understand the purpose of a switch. So again, here there is nothing special. We know already that if we are dealing with our input, we'll focus on this diagram here. Our output will focus on the logic order. And then we say every time a switch will be closed, something should change on the output. If a switch is open, don't even bother yourself to see what will become the output, because it's just going to remain the same. This is the B in or B3. Yeah, is an output. Yeah. So we can start already and identify. You can see that initially this one is open, which means you have a 0 there. Which one, because the weight is on top, it's going to be open as well. Switch 2, because the weight is on top, initially it's always on top, it's going to be closed. Switch 3 here, it's open. Switch 4, because the weight is always initially here, it's going to be closed. And then the output, initially they're always 0. And therefore, on the first step, it says press the start button. So if you press our start button, what happens is we have a 1. And because of the 1, we must check our logic diagram holder to see that when I press start button, cylinder A will go on. So you're gonna have a 1. So we have like 10 minutes. Okay, it's enough. So you're gonna have cylinder A that will go on, and everything in the circuit will remain the same. Step 2, it says release the start button. What does that mean? It means this will go 0. Because of the 0, everything will remain the same in the table. Then step 3, cylinder A starts drill. If it starts to drill, which means moving away from switch 2, and because of that, switch 2 will become what? Open. So we're gonna have a 0 there, and then because it is 0, we're gonna have 0. Everything will remain the same. Step 4, complete the first hole, cylinder A complete. And then we know complete, it's gonna be down here. So which means the lower switch will become closed. So you're gonna have switch 1, whatever name they're gonna give it, will become closed. And because the switch was closed, we check our logic order. that A will go off. So A will go off. But remember what happened to the storage. The storage, it happened when switch 1 was closed. Can you see? Automatically, storage will get a 1 as well because that switch was closed. Okay?
Okay.
Yeah. And therefore, everything else will remain the same. Step 5, cylinder A start to return. So if cylinder A start to return, is moving away from the lower switch. So this switch will become open. And then when a switch, that switch 1 is open, nothing will change in the table. It automatically. And then step 6, cylinder A is back, which means is at the top. It's on the top there. So switch 2 will become closed. So you're gonna see that switch 2 is closed. Every time a switch is closed, we check in the logic order. Then you're gonna see that cylinder B will go on. So cylinder B will go on, and everything else will remain the same. Step 7, cylinder B start to drill, which means this weight is moving away from switch 4. Whatever switch is gonna be here, it's gonna be open. So switch 4 become open, and everything else will remain the same. Step 8, cylinder B reach the maximum depth. What does that mean? It means this weight will become down here. Switch 3, whatever switch will become here will be closed. So switch 3 will become closed. And then because it's closed, we check in our logic order, B must return, which means B must go off. And if B is off, the storage as well must go off. And everything else in the circuit will remain the same. Okay, we get that part of when B is off, the storage also must go off.
Yeah.
And then on step 9, it says cylinder B start to return. So if cylinder B start to return, which means the weight is moving away from switch 3. So switch 3 will become open. Switch 3 will become open. And every time there will be a switch that should be open, everything in the circuit will remain the same. Step 10, let's say cylinder B is back. When cylinder B is back, we're going to observe that whatever switch that would be here will become closed. And then in this case, we have a switch 4. When a switch is closed, we go into our logic diagram to check, and they're going to see that cylinder switch 4 is not in part of the logic diagram, so logic order. Automatically, we're going to say that everything will remain the same. And again, we must compare to see that if 10 is equal to 0. So you can see that 10 is equal to 0. So that's basically everything that needs to be done. And to identify, we know already when to identify and when to put. So the first trick is just to know when to put the binary, the storage, and when to put. If you're not able to identify, you will go wrong with everything.
So
Yes.
on off is always the B storage.
What do you say?
On off on the logic. It's
Yeah,
always the B.
it's always yeah. If you have a on off, it's gonna be a without the storage.
Okay.
So Joe, you're basically saying that as soon as switch what? Switch one.
Yeah, the one that will be the last one to switch off the first cylinder. When it's closed, the storage must be get power. Let's go on.
Okay.
And then when cylinder B will go off, the storage must go off as well.
Okay.
Yeah. And on the problem solving, I didn't scan it. I don't know why, but the purpose is that if you go into our logic diagram, you need to identify what is the purpose of each switch. Okay. So we have the 3 switch here. I know that the purpose of switch 2 is to switch off cylinder A for it to return, and then to do what? To give the storage the power as well, so that we can start the operation of cylinder B.
Mm-hmm.
The purpose of switch 2 is to start cylinder B, to activate cylinder B. The purpose of switch 3 is to switch off cylinder B. So anything that would be asked about a switch, we must know first of all what is the purpose of a switch in the circuit. For instance, when the cylinder 1 doesn't close when touched. Remember, when it closes, cylinder A must be activated. So when it's not closed, what happened? It's not going to be deactivated. So you can see. So that's how you play
Yeah.
around. So I don't have much time. They want to kick me out.